Hi, in this video we're going to look at positional and keyword arguments for functions. So the most common way of assigning arguments to parameters is via the order in which they are passed in. In other words, their position. Just a quick example. Suppose we define a function, myfunc, with two parameters a and b. If we call myfunc using 10, 20 as the arguments, well, the first argument is 10, so it will correspond to the first parameter. The second argument, 20, will be assigned to the second parameter b. In other words, we'll end up with a equal to 10 and b equal to 20. On the other hand, if we call myfunc 20, 10, the same thing happens, except that in this case, the first argument is 20, so it will get assigned to the first parameter, and 10 will get assigned to the second parameter, since it's the second argument. And so we end up with a will be equal to 20 and b will be equal to 10. So that's just positional arguments, and it just basically looks at the position of the argument and assigns it to the corresponding parameter at the same position. Now we can define default values, and if we specify a default value on a parameter, we are essentially creating an optional argument. Let's take a look at an example. Let's say we define myfunc with a, b, but now we also write equal to 100. This is how we specify a default value for a parameter. So we're basically saying if the user doesn't specify b, if the caller doesn't specify b, then set b equal to 100. So how would we call this function? Well, we can certainly call it the usual way, 10, 20, and so 10 will go into a, 20 will go into b. That works as well, it's just positional arguments. The difference now is that we don't actually have to specify the second parameter. So we could write myfunc 5. Now when that happens, Python starts again positionally. Okay, first argument goes to the first parameter, so a will be equal to 5. But there is no second argument. So Python will look at the second parameter. Since it has a default value, it will use it. If it didn't have a default value, this would of course fail. You need to pass in as many arguments as you have non-default parameters. But in this case, we'll end up with a equal to 5 and b equal to the default value of 100. Now consider a case where we have 3 arguments and we want to make one of them optional. So suppose we have this. We have a, b, and c are the 3 parameters, and we're going to specify a default value for b, but we don't want one for c. We just want it for b. So let's say we do that. Then what happens when we call the function? How would we call this function without specifying a value for the second parameter? Maybe this, myfunc 5, 25. Well, you tell me, how would you assign these parameters to this function here? Well, it's pretty obvious. 5 should go into a. Okay, that makes sense. And 25 should go into, which one? Did I mean that 25 should be b? Or 25 should be c? Well, that doesn't make sense. Python doesn't know either. Python can't tell which one you meant to put it in. So in fact, this doesn't work at all. It won't run, right? You'll get an exception. And in fact, you can't define a function this way either. That will also result in an exception. What you have to do, the rule is that if a positional parameter is defined with a default value, then every positional parameter after it must also be given a default value. In other words, you cannot, if you start putting a default value on b, then you also have to specify a default value for c. Now, you can make the default value equal to none, if that's what you want, but you still have to specify it. So let's take a look at this example now. So myfunc with a, b equal to 5, and c equal to 10. So this is now valid because we have a default value for b, and we also have a default value for c, which is required. So now we can call myfunc 1. What will happen? It's going to put 1 into a, that's positional, and then it will use the defaults for b and c since we didn't define a second or third argument. And so we'll end up with a equals 1, b equals 5, c equals 10. Also, we can say myfunc 1, 2. What will happen? Well, it will put 1 into a, 2 into b, and then c will be its default value. So we have a is 1, b is 2, and c will be 10. We can, of course, also specify all 3 values. And in this case, we'll get 1, 2, and 3 in a, b, and c respectively. None of the defaults will be used since we specified 3 arguments and there were 3 parameters. But here's the thing now. What if we want to specify the first and the third arguments, but omit the second argument? So we want to call myfunc, we want to specify a value for A, we want to specify a value for C, but we want B to take on its default value. How might we do this? How do we specify A and C, but let B be the default? Well, obviously we cannot call it with just two arguments. If we do that, we're going to end up with 1 in A, 2 in B, and then C will be the default. That's not what we wanted, right? We can't just leave it blank or put, just a comma in there. That's going to be an exception. That's not valid syntax. So how do we go about doing this? Well, we have to use something called keyword arguments. They're also called named arguments. And basically, it works this way. We specify the name of the parameter when we specify the argument value. So in other words, we might call myfunc A equals 1, C equals 2. Python will look at this and say, okay, so you're putting 1 into A, and A is the parameter, it's the name of the parameter. So these names here, these named arguments, the names, must correspond to the names of the parameters in the function definition. So it will take 1, put it into A, it will take 2, put it into C, and since B has a default and wasn't specified here, it will just take the default for B. And so we'll end up with A equal to 1, B equal to 5, the default, and C equal to 2. So those are keyword arguments or named arguments. We can also do it this way where we can mix things up a little bit. We can put a positional argument and we can also put in a named argument. So what happens here? Well, 1 is going to go to A, that's a positional argument. B, we're not specifying a value because we're specifying C equal to 2. So Python looks at this and say, okay, you want to put 2 into C, and that's it. So therefore, it will again use the default for B, which will be 5. So we end up again with the same thing. A will be equal to 1, B will be 5, and C will be equal to 2. So that works perfectly well. So positional arguments can optionally be specified by using the parameter name. That's what we just saw. And whether or not the parameters have default values. This doesn't work only when parameters have default values. Let's take a look at a quick example of that. Let's say we have this function here with 3 parameters, A, B, and C, none of which have a default value. That means that we will have to provide 3 arguments to this function. None of the arguments will be optional since none of them have a default value. So we can call the function using the normal positional arguments, 1, 2, 3, and we'll get that A will be equal to 1, B will be equal to 2, and C will be equal to 3. Equivalently, we could call it this way. 1, 2, C equals 3. Now that's kind of silly doing that since we've already specified 1 and 2, so C is the third argument positionally. It doesn't make sense to give it, a keyword argument, but you can. It works. That's perfectly fine. And sometimes you want to do that just for readability of your code, right? You might want to specify that specifically so that the person reading the function call can tell, okay, that's what the third parameter is. You may just want to highlight that. Now, of course, you can also call the function this way with A equals 1, B equals 2, C equals 3. You can make all 3 named arguments or keyword arguments. So at this point, you may be asking yourself, well, what's the point of doing that if you don't have default, values, so you don't have optional arguments? So why would you even want to use named arguments if you just have non-default, parameters? Well, the reason for that is because now the order in which you specify the arguments doesn't matter. You can mix it up. If you want to specify C first and then A and B, that's perfectly fine. Because Python will look at this and say, okay, you want to put 3 into C, 1 into A, 2 into B, and you'll end up with the same result. So that's why we can use these keyword arguments. Even though we don't have default values, it's very useful for mixing things up. But there's, of course, a little catch to this. Once you use a named argument, all arguments thereafter must be named as well. It's a little bit like with the defaults, right? Once we had a default, everything else after that had to be defaulted. Same thing with named arguments. So this has nothing to do with the definition of the function. This is with how we call the function using arguments. If we start this way, C equals 1, 2, 3. Well, Python looks at this and says, okay, I'm going to put 1 into C, and then what? What is 2 and 3? Is that A and B? Is that B and A? Was that B and C because it's second and third position, but I've already defined C, right? So there's a lot of ambiguity there, and therefore this doesn't work. The syntax is not valid. Same thing, right? If you do 1 comma B equals 2 comma 3 for the same reason, you've got a keyword argument here. You cannot specify a positional argument afterwards. Yeah, you and I can probably look at this and say, okay, I understand what you meant. 1 was supposed to go to A, 2 it goes into B, and then 3, well, that's the last parameter. You know, we don't have any other parameters that will go into C. But what if you'd had A comma B comma C comma D, right? And then D had a default value, for example, and you specified 3. Well, was 3 for C or 3 for D? Or, you know, again, it's too ambiguous. That won't work. And in fact, you'll get an exception as well if you try that. The only thing that works is once you start using a keyword argument, a named argument, you must use keyword arguments thereafter for every other argument that comes. So this is okay, right? We can start with a positional argument, 1, so that will go to A, and then we have these named arguments. We have these keyword arguments, B equals 2, C equals 3. That works. And of course, the order of the keyword arguments does not matter, which means that this works equally well and does exactly the same thing. A will get 1, C will get 3, and B will get 2. And we end up with the same thing. And so that's correct as well. So, as we just saw, all arguments after the first named or keyword argument must be named too. It must be a keyword argument as well. Now, of course, default arguments may still be omitted. Let's take a look at an example. Suppose we define this function myfunc with 3 parameters, and B and C both have default values. Then we can call myfunc1. It's just using the normal positional arguments. So 1 will get into A, and then since we haven't specified B or C, they will get their default values of 2 and 3 respectively. Alternatively, we can just use keyword arguments. So A equals 1 and B equals 5, which means that A will get the value of 1, B will get the value of 5, and then C wasn't specified, so it will just take on its default value of 3. And so we end up with A equals 1, B equals 5, C equals 3. Now, of course, the order of keyword arguments doesn't matter, so we can also do it this way. We can call myfunc with C equal to 0 and A equal to 1, in which case 0 will go into C, 1 will go into A, and since we didn't specify B, it will just take its default value of 2. And so this is what we end up with. Alright, so let's switch to some code and let's just see how all this works. Thanks for watching, and I'll see you in a bit.